Right now, someone may be copying your company's encrypted data and not for the reason you suspect. It's not an error. It's not a miscalculation on the attacker's part. You should not be patting yourself on the back thinking everything is secure because your traffic's encrypted. The attackers are recording your encrypted transmission intentionally and storing it. Why would they do that? Well, they're playing the odds like any good gambler would, betting that in a few years a machine or tool will exist that cracks it wide open. The day it pays off has a name, and people at the world's biggest security conferences have been talking about it for a while now. The name is Q-Day. I try to track priorities in the security industry, and this past year, one theme kept surfacing. Not ransomware, not phishing, quantum. This isn't a 10 years from now problem. It's a today problem as discussed in NIST's PQC project laying out its PQC standards. One of the people who literally co-authored the new defense standards gave a talk on how to survive the transition in Transition to Post-Quantum Cryptographic Standards, NIST IR 8547 IPD. And the people in the know already have a plan. But what's your quantum-safe roadmap? If your organization can't answer that question now, you're already lagging behind. This is not a fear tactic, it's just facts. The situation is going to turn into another generation's Y2K bug. If you spend time now patching, testing, and confirming your setup, Q-Day is going to come and go without being a bad day for your company. Here's the play. An attacker doesn't need to break your encryption today. They just copy it and wait. Think about the data that stays sensitive for years. Merger plans, contracts, customer records, health data, secure source code, anything still viable 5 or 10 years from now. Encrypted today, and a patient adversary can simply hold it until the key that protects it is worthless. We've seen encryption get cracked before, but in the past, it wasn't at the top of people's minds to stockpile encrypted data, or as the technique is starting to be referred to as harvest now, decrypt later, HNDL. With the advent of AI and the advancements we're making in today's technology-driven world, something like quantum computing is no longer a pipe dream. It's something that is coming closer to reality. The reason HNDL might pay off is because the locks we've used for decades rely on math problems. And it's not going to be a team of mathematicians trying to solve your very complex math problem. It's going to be a quantum computer uniquely built to solve your math problem. Attackers are not breaking in, they're collecting and being patient. What we're talking about isn't speculation, it's on the calendar. And the part most executives miss is that the biggest names have already moved. The browser you're watching this in, your phone's messaging, the networks behind major websites, many are already running the quantum-safe version in production today. What they're running isn't some exotic replacement, it's a hybrid key exchange called X25519MLKEM768. That name is really two algorithms stacked together. Pairing them means that the connection stays at least as strong as today's encryption, while adding a lattice-based layer built to resist future quantum computing. Chrome turned it on already, Firefox has followed suit, and Cloudflare has been negotiating it on TLS 1.3 for years at this point. On the messaging side, Signal ships PQXDH protocol, did that back in 2023, and Apple's iMessaging rolled it out early 2024. What's deployed today protects the key exchange. It stops the harvest now, decrypt later tactic. The authentication side, the digital signature on certificates, is still catching up, and that's the next front in this migration. So what do we actually do? Understand first that this isn't a product you buy, it's a migration you plan internally. The plan starts with the question that most organizations can't answer. Where are we even using vulnerable encryption? Most have no inventory. That's step 1, make your encryption inventory. Step 2, confirm crypto agility in your systems. A system with its encryption hardwired in has to be rebuilt to change it. A system designed to swap its encryption gets reconfigured instead. The first is a project measured in years. The second is a configuration change, not a ground-up rewrite. The organizations that win this battle in the next decade are ones that can change their encryption without rebuilding their programs, but agility probably isn't a setting you already have. It's a design property you build on purpose. Step 3, make sure your programs can actually use PQC and treat it as a setting that gets reviewed on schedule, just like any other security control under compliance oversight. Now I hear what you're saying, that's all easier said than done, I get that. And the detailed process looks very different depending upon what your company does. If you're mostly consuming software, SaaS tools, cloud platforms, off-the-shelf products, You're not rewriting cryptography. You're making sure your vendors give you the ability to stay current. That's one uncomfortable but important question added to every procurement conversation and every renewal review. What's your post-quantum roadmap, and when does it land in the version I'm running? If a vendor can't answer that, you've just found a risk that wasn't on your registry yesterday. And if it's a vendor you share regulated data with, PHI for example, that question moves up the priority list real fast. If you're producing software, your job is to build for easy replacements of cryptographic methods from here on out, so the next swap is a design you already planned for and not a rebuild or a redesign of your product. For years, we treated encryption as a set it and forget it decision. Pick a strong algorithm and move on. That era is over. The time is here where encryption is now a living part of your attack surface. Something with a shelf life that has to be inventoried, versioned, and reviewed on a schedule, the same way you patch a server or rotate a credential. The threat here isn't a breach tomorrow. It's harvest now, decrypt later. Data being copied today and sitting in storage until the hardware exists to crack it, which means the clock on anything you need to keep secret for 5, 10, 15 years is already running. So just to cover what we talked about, step 1, build the inventory. Step 2, build in crypto agility. And step 3, treat PQC as a standard control, not a one-time project. You don't have to finish this migration in the next several quarters, but you do need to start it now. People already using PQC are not ahead by accident. They just stopped treating encryption as a set and forget and started treating it as an infrastructure that requires attention. When someone asks your organization, what's your quantum readiness roadmap? Do you have an answer? Want to see this for yourself right now? Open your browser and check whether your traffic is already protected with services you're using. The clock for Q-Day is ticking. The only question is whether you're ready before it arrives. Every command in this lab runs against the loopback and my own browser. No third-party system is touched, so no scope agreement or written authorization is required. Now what we're going to do here in the first demo is set up 3 different terminals. The first one we're going to set up is going to be our local TLS server, and it's going to act as our web server for the time being. The second one we're going to set up is going to be the Wireshark tap, and the third one we're going to set up is going to be our client connecting to the web server. So in essence, in this lab, what I'm just trying to do is show you, here's the server, the web server, here is the wiretap in the middle using Wireshark, and then on the other side would be the client trying to reach out to talk to the server. This is an example of how the attack path would work. Of course, we're doing this all in our home lab. So in essence, this would be a web server on the internet somewhere, and they would somehow reroute the traffic and be able to look at the traffic you're sending to the server, and the client over here is your web browser. And what I'm going to do now is just take the encryption key and just to show you how it might look if someone were to get your encryption key for the traffic back and forth, and how they would use it in Wireshark to decrypt the traffic. Now, of course, this would only happen if someone knew what your key was on the other side, or the idea here is once someone understands how to crack the encryption because of quantum computing, they can take those keys and just do exactly what I'm doing in Wireshark to decrypt the traffic that they have stored. And that's the video. If this helped you out, please let me know, drop a like, subscribe if you're new here, and I will see you in the next one. Thank you.